Okay, so today's lesson is applications that involve percents, basically more word problems and things like that, but ones that are specifically geared around percents and percentages. So the main concepts here is being able to translate basic percent equations from English into math, and then obviously being able to solve them. And then some applications that involve simple interest, and then discount and markup, which is a fancy way of saying percent change. So let's first look at these basic percent equations. A new camera costs $429.95. Compute the sales tax if the tax rate is 4%, and then determine the total cost, including tax. Well, anytime you have to add tax to something, or add a percentage to something, you can do it in two steps. Excuse me. Or you can take a shortcut and do it in 1%. Because if you have to add 4% to something, well, you start with 100% of the cost. And so if you add a 4% tax, the total, right, you can think of this as, price plus tax, your total is going to be 104% of the price, right? You get 100% of the price plus 4% of the price as tax, you have 104% of the price. Well, of means multiplication. 104% written out, right? So 104% of 429.95 is your total. We just have to realize, how do I work with 104%? Well, 104%, remember, is 104 per cent is just Latin for 100, and that just becomes 1.04 as a decimal. Multiply that by 429.95, and that's going to give you your total amount. Now, if you want just the sales tax, then of course you just take 429.95, multiply it by 0.04, and then you could add that in, of course, to get your total. So if you had something like this where you had to do both, it's obviously easier to just do 4% of it first, figure out what that tax is, then add it to figure out what the total is. But if they don't make you do this intermediate step and they just say, hey, if you pay 4%, what's the total cost? Then you can kind of cut the corner and get it quicker by just doing 104% of it. So obviously if the tax rate was 6%, it'd be 1.06, and so on and so on and so forth. So that's what a percent change question is all about. If your percent is going up, you just add it to 100, and then if your percent is going down, you subtract it from 100. And we'll see some examples of that a little later. Here's a second one. You've got a group of 240 college men were asked what intramural sport they most enjoyed playing. The results are in the graph below. What percent of the men surveyed preferred tennis? Well, a percent, right, is how many you have divided by the total. So in this case, we have 30 that like tennis, and then the total is 90 plus 20, that's 110, plus 60, 170, plus 30, 200, looks like 240. So you'd want to figure out what that is as a decimal, right? You could do this, and then you could make it 1/8. That's not really going to help you because we can't figure out what the hell 1/8 is as a decimal, but 1 divided by 8 is 0.125, which as a percentage, right, is 12.5%. All right, so another example. Andrea spends 20% of her monthly paycheck on rent each month. If her rent paycheck is $950, what is her monthly paycheck? This is one of those typical translation ones I mentioned. So they're telling us that 20% of her monthly paycheck goes on rent, and her rent payment is $950. So $950 is 20% of paycheck, right? Because that's what we don't know, right? What is her monthly paycheck? We're solving her P. So 950 equals 0.2p, and then all we have to do is divide by 0.2 to solve for p. So we got 950 divided by 0.2. And her monthly paycheck is $47.50. The next concept is just looking at some applications involving simple interest. So Jorge wants to save money to buy a car in 5 years. If Jorge needs to have $20,250 at the end of 5 years, how much money would he need to invest in a certificate of deposit, a CD, that gives you 2.5% interest rate? Now, they're saying simple interest, so we're going to assume this is simple interest, right? Because they don't tell us anything else. So you need to know what the formula is for simple interest, and it's really quite easy. It's the amount you have is your principal times your interest rate. Let's see, simple interest. I can never remember this one. I think simple interest rate is times years. No, it would be to the power because you get. Well, no, simple interest means it's not compound interest. So you're just getting 2.5% 5 times of the original amount. Yeah. I never remember simple interest because it doesn't exist in the real world. It's kind of a simple thing. It's a stupid thing. Everything's compound interest, so it makes more sense to talk about compound interest. But in any case, I'm pretty sure this is the formula for simple interest. And then it's just a matter of plugging in what you know, right? 20,250. Your interest rate is 0.025. Remember that you always have to list interest rates or any kind of interest question as a decimal. And then you're going to do that for 5 years. Because the idea with simple interest is you get 2.5% of the starting principal. And even though you have more money in it at the end of the year, you still get 2.5% on that starting principal. So you're basically just getting that same amount 5 times. So if you wanted to, you could literally just do 20,250 times 0.025. And you're going to get $506.25. That's how much interest you'd get the first year. Well, the second year, because it's simple interest, you're still getting that same amount. So you're really just getting this 5 times. So that's why we just multiply it by 5. And so you end up earning $2,531.25. That's simple interest. Compound interest makes more sense. Compound interest is what happens in the real world. And that's your principal times 1 plus r over n to the ny. A little bit more complicated, where n is the number of compounds per month, and r is your interest rate, and blah, 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 blah. But we don't have to deal with that here. We're just doing simple interest. All right, our last concept are applications involving discount and markup. This is that thing where I'm talking about percent increase, percent decrease. So after a 38% discount, a used treadmill cost $868 on eBay, and they want to know what was the original cost of the treadmill. So this is that idea where I'm talking about percent difference, right? The price that we're trying to find, the original price, started at 100%. I know it's just 100% is the original price. But then we took away 38% for this discount, which left us with 62%. 62% of the original price is still there, and that's what equals 868. So we can now write this out mathematically. 62% of the original price is 868. So that's the key to doing these discount and markup questions, is you always have to translate it into a percent of question. Not a percent more, not a percent less than, because those don't work. You have to do a percent of, because then that's just multiplication. So if you can figure out what percent you end up with, then you're literally just multiplying that by something to get an answer. So in the case of this, right, to solve for it, you've got 0.62p equals 868. You divide both sides by 0.62. And we've got 8 68 divided by 0.62, $1,400. That was the original price of the treadmill. Okay, then that's all I've got for you for applications involving percents.